It's pretty peaceful here right now, but it wasn't very peaceful here in this whole southern cruise-off island for several hundreds of thousands of years. Why, there was a lot of volcanic activity and probably a lot of earthquakes with that. And certainly towards the end there were the violent eruptions of the ash deposits.
This is the Mount Edgcumbe volcanic field. Located 16 miles west of Sitka, it covers the southern half of Cruise-Off Island, an area of about 100 square miles. Two major fault systems are adjacent to the field. One runs through Neva Straits, Sitka, and Silver Bay. The other runs under the ocean, connecting the Fairweather Range and the Queen Charlotte Islands. Geologists theorized that a fracture between these faults created a weak spot, allowing Mount Edgcumbe and more than a dozen other volcanic vents to form on the island. Mount Edgcumbe is the largest of the volcanic cones with an elevation of 3,200 feet. It was created by a colorful combination of lava flows and ash deposits.
When the light is on Edgecumbe, you not only see the red, but you see a lot of orange and you see a lot of yellow. And it's really a spectacular combination of colors, and those colors represent different ash layers and different lava flows that are in that cone. And the reason that Edgecumbe built itself up and stayed up is that it's this alternation of ashes and lava flows that are coming out from the central vent area.
Potassium argon and radiocarbon dating techniques reveal Mount Edgcumbe to be about 35,000 years old. But more recent and more violent eruptions happened elsewhere on the island. At nearby Crater Ridge, large amounts of hot ash were hurled into the air 10,000 years ago. These ash explosions are a dramatic contrast to the earlier, more peaceful lava flows of 600,000 years ago.
This is really an exciting place because we are at the bottom of the volcanic pile in a place where the rocks are probably amongst the oldest rocks in the whole volcanic field. So we're looking at where it all started, and we're looking at rocks that are a combination of sedimentary rock like a sandstone or shale and volcanic rock. The pieces that you see, the volcanic pieces, come in a big variety of shapes, and some of them are quite rounded and are called pillows. They're where liquid rock or magma came into the water and immediately cooled and assumed a kind of a spheroidal shape. Then there are other ones that are very angular, and those also are from the magma coming right into the water and shattering. But this is a good example of these aquagene tuffs, these volcanic rocks that formed when the lava came right into the ocean and shattered. This rock has a lot of small, angular, black fragments in it, and those are almost pure glass. Some of the gray fragments are a different kind of rock, and there are about 3 or 4 different kinds of volcanic rock in here. And what this says is that this part of the ocean was getting a variety of magmas into it in probably a relatively short span of time. This is exactly the kind of rock that we got the microfossil out of.
Just as marine fossils indicate this part of the volcanic field began underwater, other clues reveal that a glacier partially covered the field between eruptions.
Underneath this flow, there's a layer here that has boulders of granitic rock in it, and then below this layer with the granitic boulders there are more lava flows. Well, these rocks down below, over there, are about 300,000 years old, and these rocks here are about 45,000 years old. So during that time, these boulders somehow got in between. Well, the boulders we know came from a rock unit that's exposed further north on Cruise-Off Island. They've been rounded, and they were transported by a glacier and deposited in Glacier Hill, which is up on the hillside there about 150 feet above us. And then normal beach processes, erosive action along this shore a long, long time ago, let those boulders come out of the glacial till down onto this old ancient beach here, where they were resting when this lava came along about 45,000 years ago. What caught my eye here was the possibility that this is an old lava tube, and a very large one. And The way those things form is that the lava is flowing along and it starts hardening from the outside in, and it piles itself up, and so you get a hard outer shell and you have the molten inside, and then the molten inside flows away from the outside and it leaves just the rim standing. And in this case, I think that's what we're seeing. There probably was a roof over this, and the roof has been eroded off by the action of the sea. This whole west side of the island has features like this, lots of domes, lots of tubes, many of the volcanic features that you associate with lava flows on Hawaii, actually you can see here on Cruzoff just as well. Down the shore is kind of a nice feature. We're seeing here the juxtaposition of some of the oldest features in the volcanic field and some of the youngest ones. This is an ashfall deposit. Now, not all the stuff here is ash. It's too coarse grain. There are blocks and bigger pieces in here. It's almost all glassy material, and it's one of the younger deposits in the whole volcanic field. It was blown into the air. This one probably came out of Mount Edgcumbe itself, went high in the air, tens of thousands of feet possibly, and then came right straight back down. These great big pieces are clear indications that it hasn't come obviously too far. There are other things in the rock other than the glassy material, which is the original material of the eruption. There are dark fragments of different kinds here. These are pieces from the throat of the volcano that got chewed off in the eruptive process and got entrained with the glassy material and formed this steep cliff. When you look up along the cliff, there's a horizontal surface, and that's the break between this unit and the unit up above. That actually has a little sediment on it, and it indicates that there was some kind of interruption time-wise. Now, probably not very much, because the best information we have suggests that these deposits right here are about 11,000 years old. The unit that's up above, we know from a date that we got on some wood not very far from here, it's about 9,700 years old.
Ash from these eruptions covered much of northern southeast Alaska. In Glacier Bay, ashfall measured ½ an inch. In Juneau, nearly an inch fell. And in Sitka, the fallout averaged more than 3.5 feet.
If there were an eruption of the kind that happened about 11,000 years ago, right now, Sitka would be in serious trouble, because there would be recurrent ash flows, accumulations of probably up to ½ a meter at a time, and there would be no mechanical devices that would be working, no engines, no airplanes, no cars, anything of that kind. And so when you look around Edgecumbe, or look around Sitka, you can see the Edgecumbe ash, and it's up to 1 meter thick, 2.5 meters thick, I think is the maximum that was measured over there. And so that's a lot of ash. And it didn't all come at once. All the ash that we've been talking about probably came out sporadically over a period of about 1,000 years. And it came with warnings. So had there been people in Sitka at that time, and had they known what we know now, they would have known that something was going to happen, and hopefully would have gotten out of there.
The most recent eruption in the Edgecumbe volcanic field happened between 4,000 and 6,000 years ago. It was a relatively small event, perhaps smaller than the recent eruptions at Mount Spur near Anchorage. There is a high probability that a core of molten rock still exists 6 to 12 miles under Mount Edgecumbe and Crater Ridge. That core is slowly cooling, and unless something happens at a greater depth, future eruptions seem unlikely.
One thing that contrasts this field with other fields that are about the same age and look about the same is that there are no hot springs here that are associated with Edgecumbe. There are no fumaroles. There are nothing of that kind that you find in almost all of the Cascade volcanoes. And there are no warm spots. As far as I can tell, all the pilots who fly around here have never told me, and I've asked them off and on, is there any place on the mountain where the snow won't stay during the winter? And no, it seems to stay everywhere. This all seems to be cool at the surface and dormant, if not extinct.